Hey, welcome to The Explainer. Today, we are going to tackle something huge. I mean, literally. We're talking about how we take a mountain of rock and pull out the essential metals that build our modern world. So let's just dive right in.
So look at this. On one hand, you've got a mountain, and on the other, a smartphone. How do you possibly get from A to B? It seems kind of impossible, right? This entire explainer is about that incredible and honestly pretty wild industrial journey that makes it happen. And this journey isn't just about using big machines and brute force. It is a world of incredibly high stakes precision. Our source material really hits the nail on the head with this quote. We're talking millions of dollars on the line, and those decisions are based on analyzing just a tiny, tiny fraction of all that rock. If you get it wrong, well, that's a very, very expensive mistake. Okay, so here's the fundamental problem. The good stuff, the copper, the gold, whatever we're after, it isn't just lying there in nice big chunks for us to pick up. No, it's usually microscopic specks, and they're locked up tight inside tons and tons of worthless rock. And that worthless rock, it has a name in the industry: gangue. So our whole goal here, it's to stage a prison break for those minerals. And step one of any good prison break is to, well, break the prison. This first part of the process is what we're going to call the big shrink. The fancy technical term is comminution, but really all it means is we have to make some very, very big things very, very small. Yeah, there's really no delicate way to put this. We start with absolute brute force. We take boulders, and sometimes these things are the size of a car, and we just begin the long, violent process of smashing them into smaller and smaller pieces. And the tools for this job? They are absolute monsters. Machines like jaw crushers and gyratory crushers, they're basically giant mechanical teeth. They use immense, immense compressive force to just squeeze and shatter those car-sized boulders into something a whole lot more manageable. But crushing is just round one. From there, these now smaller rocks get fed into these enormous rotating drums called mills. And inside, huge steel balls or rods are tumbling around, just constantly grinding the rock down, taking it from gravel all the way to a fine powder, kind of like flour or dust. And the sheer scale of this size reduction it's just staggering. A pretty typical reduction ratio inside one of these mills is 200 to 1. To put that in perspective, that's like taking a full-sized basketball and grinding it down to the size of a single tiny grain of sand. Wild. So, why all this insane crushing and grinding? Well, it all comes down to one single, absolutely critical purpose: liberation. This is the moment. This is when our microscopic prisoners are finally broken free from their rock prison. The valuable mineral particles are now physically separate from that worthless gangue. But, of course, that just creates a whole new problem. All right, so our minerals are liberated. They're free. But now we're in the second major stage of our journey, what we'll call the great sorting. We've just created a massive pile of dust, right? So how in the world do you separate the microscopic bits of gold from the mountains of worthless gray dust? I mean, think about it. You can't use a sieve. They're way too small. And you definitely can't pick them out by hand. So what do? Well, this is where the brute force ends, and some truly clever chemistry takes over. The solution sounds, honestly, a little bit like magic. It's called froth flotation, and it is hands down one of the most important, most elegant processes in the entire mining industry. And the whole thing works on one simple idea. You have to make the minerals hate water. So here's the science behind it. It's all about exploiting two opposite properties. The gangue, the waste rock, we just leave it alone. It's what you call hydrophilic, which just means water-loving. It gets wet easily, sinks right down. But the valuable mineral particles, we treat them with a special chemical that makes them hydrophobic, water-hating. They want absolutely nothing to do with the water. So here's how we pull off this trick. First, we mix all that powdered rock into big vats of water to make a slurry. Then we add a special chemical, it's called a collector, that acts like a tiny waterproof jacket, and it only sticks to the mineral particles. Next, we pump air bubbles up through the whole mixture. Now for those water-hating mineral particles, these air bubbles are like life rafts in a storm. They grab on for dear life, get carried up to the surface, and form this thick, mineral-rich froth. And then we just skim that froth right off the top. It's basically a giant industrial bubble bath that magically separates metal from rock. Okay, so after all that crushing and grinding and bubbling, what did we actually accomplish? Was all that work worth it? Let's take a look at the payoff, because this is where you see why this whole complicated dance is so important. And the result is, well, it's dramatic. We might start with ores straight from the mine that has less than 1% copper in it. I mean, that's not useful for anything, really. But after all this processing, that final froth we skimmed off, the mineral concentrate, it can be over 25% copper. We have concentrated the value by more than 25 times. And that concentrate, that is what this whole thing is about. This is the stuff that then goes to a smelter to be turned into pure metal. It is the literal starting point for the copper in our electrical wires, the iron in our skyscrapers, and all those different metals that make up these super intricate circuits inside the very phone you might be watching this on right now. So this incredible journey from a mountain to a piece of metal is pretty much the foundation of our entire modern world. But it leaves us with a pretty big and pretty critical question for the future, doesn't it? When all the easily mined mountains are gone, what's our path forward then? Something to think about. Thanks for joining me on The Explainer.